Now we move on to the last subtopic for this chapter. That is, we are dealing with force and acceleration, and we are talking about general plane motion. Okay, so we're still interested in the equation of motions. Okay, so this is taken from the Newton's second law of motion. Okay, Newton's second law, and it states that the total force is equal to mass times acceleration, and we have broken down into x and y axis. Okay, so sum of forces in x-axis equals to magx, total force in y-axis equal to magy, and we also calculate the moment because there is a rotation, which is equal to ig alpha, and ig, we have explained that this is the mass moment of inertia. Okay, all right. And the moment equation, we can calculate about g. This is about center of gravity. We can calculate about any point, for example point P, and we will have this is what we call as the kinetic moment, all right, which in which we calculate the moment based on the kinetic diagram. And also we can calculate the moment about the IC. Okay, I hope you still remember what IC is. This is the instantaneous center, of zero velocity. So if you have forgotten what IC is, you can go back to the kinematics chapter and look at the definition of IC. Okay, we're going to move on to the first question. So this is a general plane motion question. So how do you know that? You will see that as this cylinder rolls, the 100 kg cylinder rolls, okay, so it will be, because of this 200 Newton force, it will be rolling in this direction. Okay, so there will be rotation. Okay, this is rotation, and at the same time this center of gravity G is also traveling to the right. Okay, this is translating to the right. So you have a combination of translation and rotation, and that is why this falls under the category of general plane motion. Okay, to solve this question, before that, let's look at what are the parameters that we have to calculate. So the question asks us to calculate the acceleration of the mass center, which means that the acceleration of this center of gravity G, and also its angular acceleration. So what the question wants us to calculate is what is AG, as well as what is alpha of the cylinder. Okay, so we will start with the free body diagram. All right, definitely there will be weight. Okay, and you'll see that there is a contact point between the cylinder and the ground. Therefore, there will be a normal force at that point, and there is a pulling force of 200 Newton. So altogether you have three external forces acting on the cylinder. Now we move on to the, before that, sorry, because it says rolls without slipping, therefore there is friction involved. So you have to include as well the component of friction. So this is the friction force, Fr, if you want. Okay, the friction force is given by mu times Na. So mu is not given in the question, so we don't know what is the coefficient of friction. Friction mu is unknown. Okay, so that is one of the things that we have to find. All right, so now let's look at the kinetic diagram. definitely this thing will move to the right, so you will have magx component. It will not move up and down, so there will be no y component, but this thing will rotate. So you will have two arrows in the kinetic diagram. One is pointing to the right, the other one is the rotation component ig alpha. Okay. So we will start with the first equation, that is total force in x-axis equal to magx. All right, you look at the x component, the x-axis. Okay, now you'll see that we have 200 Newton force in x-axis, and we have the mu na component in x-axis for the left hand side, and for the right hand side you have this magx. So we'll combine all this, so we have 200 positive plus mu na positive equal to m is 100 times agx. Okay, so that completes the first equation. Nothing much we can do here, so we proceed with the y component. Okay, for the y component you have several items as well. In y component you have na positive, you have mg negative, and there is no y component in kinetic diagram, so this will be equal to 0. So straight away you will get the value of na, which is equal to 981 Newton. Okay, but we haven't determined what is the acceleration and what is the angular acceleration of the cylinder. Now, let's move on. We go to the moment equation. So now I'm gonna calculate the moment about the center of gravity. All right. So mg. Now you look here. I define clockwise rotation as positive because this cylinder here is rotating clockwise. Okay, so it will be easier to define the direction of rotation as the positive direction of our moment equation. So we take clockwise as positive. So when you calculate moment about g, so how many moments do you have about center of gravity? This one, mg, no moment about center of gravity. 200 Newton force, you don't have moment about center of gravity. Normal axis, normal force also, you don't have moment about center of gravity because all of this fall directly on point G. So there is no vertical or horizontal distance. So the only force that has a moment about G is this force. Okay, this friction force, which is rotating in counterclockwise going to point G. So you will have minus mu na times the distance is the radius, and that is the left hand side of the equation. So when you look at the right hand side, you will have to find out what is ig. Okay, and here comes the use of the table which I will be providing to you. Okay, so this is a cylinder. Although in the picture it doesn't look like a cylinder, but if you look closely, this actually should be looking like this, as a cylinder in three-dimensional. So that is how this thing looks like, right? Okay, I'm gonna erase this first. Okay, all right. Now by looking at this table here, you'll see that this is rotating about this axis, right? About z axis. Okay, so we're going to use IZZ formula. Okay, so you will have IG is 1 over 2 times M is 100 and R is 0.3 square. So you'll get 4.5 kg meter square for the IG. So when you bring all the equations together, you'll have minus mu and A times 0.3, this one that I have explained previously, equal to 4.5 alpha. Okay. All right. So we still cannot solve the problem here because you'll see that here we have still we have a lot of unknowns. All right. Alpha is unknown, mu and A is unknown as well. So and also AGX is also unknown. So we need another equation to solve this problem. So let's look at the question again. It says rolls without slipping. What does it mean? In kinematics chapter, I think I have explained that if it says rolls without slipping, it means that the contact point between the rigid body and the ground is actually the IC, the instantaneous center of zero velocity. We have discussed this in the kinematics chapter. So what does IC means? IC means that this is the IC point is basically similar to the center of rotation. Center of rotation. We can say it like this. So when this becomes the center of rotation, you will have the tangential component. Remember, tangential component is tangent to the path, and the normal component is pointing to the center of rotation. All right. But in this case, the tangential component AT is equal to AGX, and from the previous derivation, we have said that AT is equal to alpha R. And AN, because there is the cylinder is not moving up and down, so basically the component AN equals to 0. So this is the thing that you should remember. When a question says that it rolls without slipping, you have an extra equation that you can use, that is AG equal to alpha times R. Okay, so when you have this equation, we can substitute this AG value up here. So AG here becomes, let me erase this, AG here becomes 0.3 alpha. Remember, R, AG is alpha times R. R is 0.3, so AG becomes 0.3 alpha. Now, when you have AG equals to 0.3 alpha, we can rewrite this equation to become 981 mu. This comes from NA here, 981 mu, plus 30 alpha. You bring this one to the left hand side, equals to 200, and you can rearrange the this equation, the third equation, to become minus 294.3 mu minus 4.5 alpha equals to 0. So now you have two sets of equation. This is equation 1 and this is equation 2. Now you can solve these two equations simultaneously. You will get mu is equal to 0.068 and alpha is 4.44 rad per second square. Now you still have to calculate AG. Now we go back to this equation over here to get the value of AG equals to 1.33 meter per second square. Okay, so that is how you solve the problem with that involve general plane motion. I'm going to show you another example here. Let's say that previously we calculated everything. We calculated the moment about G, center of gravity. Now let's try to calculate the moment about IC. We can do that as well. So remember in the earlier slide I showed that you can calculate moment about IC, which is equal to IIC times alpha. Now when you have something, the mass moment of inertia about other point, you have to use the parallel axis theorem to get the value. Remember from the previous tutorial? So IIC using parallel axis theorem. Okay, this is parallel axis theorem. Says that IIC equals to IG plus MD square. And what is D here? D is the distance from center of gravity. This is G to the center of rotation. So IC now is the center of rotation. So basically this is D, which in fact is also equal to R. So that's why you have 0.3 here. Now when you multiply, you will have IIC equals to 13.5 kg meter square. Now, when we substitute everything on the right hand side, on the left hand side, the moment calculation about IC, this is now the IC point. So basically mu NA, no moment about IC, NA, no moment about IC, mg also doesn't have moment about IC. The only moment you have about IC is this 200 Newton moment, and it is going like this in clockwise direction, so it is positive to IC with the distance of 0.3. So 200 times 0.3 equals to 13.5 alpha. Therefore, with this method, straight away you will get alpha equals to 4.44 rad per second square, and you will substitute in this equation to get AGX equals to 1.3 meter per second square. So you have two options in this case to calculate the moment about G or to calculate the moment about IC.